Hi guys, welcome to lesson 10.2a, Simplifying Radicals. For this lesson, we are also going to be including parts from lesson 7.5, which we skipped way back in January. Our goals today, we're going to simplify radicals involving products, and we are going to rewrite expressions involving radicals and rational exponents. So let's start with our vocabulary today. A radical expression is an expression that contains a radical such as 2 root 3 or the square root of x plus 3. So this symbol right here is the radical, right? A radical is simplified if all of the following are true. First, the radicand has no perfect square factors other than 1. Second, the radicand contains no fractions. And third, no radicals appear in the denominator of a fraction. Okay, so I used a vocab word there that we haven't been introduced to yet, and it is radicand. So the radicand is what is under the radical sign. So when we're looking at that, it's this piece underneath the radical symbol. So a radicand, the piece under the radical, can contain no fractions when we are simplified. The index tells us the degree of the root, and it's right here. Now, you'll notice up in our first two examples here, there is nothing written there. If there is no index shown, we are assuming that it is the second degree, so it's a square root. Anything else, if it's a cube root or anything higher, fourth root, fifth root, there will be a number where that n is in our definition. Okay? Otherwise, if not, it's a square root. Now, we have the multiplication property of square roots. So the rule is for a is greater than or equal to 0 and b greater than or equal to 0, the square root of a times b is equal to the square root of a times the square root of b. So what this says is we can break square roots down into pieces and simplify the pieces of them as we can. So our example here is square root of 48 can be broken down into 16 and 3. Those are two of the factors of 48. And we can take the square root of 16, which is 4, and the square root of 3 just stays the same because there is no perfect square in there. So problem number 1, we're going to focus on removing perfect square factors. So if we zoom in on letter A, we're going to break 72 down into its factors. And the way we're going to do this is we're going to use a factor tree. And so we're going to break down and find what are some of the factors that make up 72. We can go with a 6 and a 12. 6 times 12 is going to be 72. Do we have any perfect squares here? No, we don't. So we're going to bring it down to another level. 6, if we go to prime factors, is 2 and 3. 12, we're going to break it down further. 12 is 3 times 4. And then if we take it to another level, we're going to break the 4 down into its prime factors. We've got a 2 and a 2. So we're looking at a square root here, right? Our radicand is not shown, so it's a square root. Square root is, when we take a square root, we are looking for factors that are going to be pairs in there, right? Because if we take a square root of 4 is 2. 2 times 2 is 4. So we're looking for pairs inside of our terms. So we've got a pair of 3's right there, and we have a pair of 2's right there. So what we're going to do is we are going to bring out the 3, and we're going to bring out the 2, and they're being multiplied. And what do we have left under our radical? The only prime factor we don't have used is that 2 right there. So it's 3 times 2 times the square root of 2. 3 times 2 is 6 times the square root of 2. Okay? So another way, if you had looked at prime factors, actually no, we'll do that on the next one. So letter B, we have the square root of 125. We know 125 is not a perfect square already, so we're going to break it down into its factors. We have 25 and we have 5. Now, as I look at those factors, do I have something that I can take the square root of? I can. It's 25. We know that the square root of 25 is 5, but I'm going to show you the prime factors anyways because we're looking for this pair, right? 5 times 5 is giving us 25. So when we take the square root of 25, because we can rewrite this as the square root of 25 times the square root of 5, what's the square root of 25? It's just 5, and we have the square root of 5. So this is our simplified form of the square root of 125. Okay. Now, 126. As I look at this, I don't know the factors of 126 off the top of my head. So I'm going to need to break it down. I know it's an even number, so I know I can divide by 2. And when I divide 126 by 2, I get a 63. Okay, that's a number that I'm a little more familiar with. I'm still going to break it down into its prime factors. So 63 is going to be 7 times 9. 7 is prime, but 9 is not. We break it down to 3 and 3. So if I'm looking for what are my pairs of prime factors that I can take the square root of, I have 2 3s right there. So that tells me I can bring a 3 to the outside of my radical. And then what do I have left inside? I have a 2 that has no pair, and I have a 7 that has no pair. And then we simplify. 2 times 7 is just 14, and we have the 3 out in front. Okay. Now, I want you to pause and complete letters D, E, and F on your own. Go ahead and pause, simplify letters D, E, and F. With letter D, we're going to start by breaking down our factors, and we're going to use the factor tree. 98 breaks down into 2 and 49. 49 breaks down into 7 and 7. We have our pair of factors right there, so we can bring out a 7, and we are left with what's not highlighted, a 2. So we have 7 times the square root of 2. Now you can double check all of these using your calculator. All you have to do is put in the square root of 98, hit enter, and then do 7 times the square root of 2, and you'll see you have the exact same decimal factors. All right, letter E. I don't know factors of 288, but I do know that 288 is even, and I can divide that by 2. And I'm going to do that. So 2 and 144 are my 2 factors there. And 144, if we break it down, breaks down to 12 and 12, because that's one of my perfect squares. So if you remember way back in chapter 7, I encouraged you to memorize your perfect squares. This is one of those times when that memorization is going to come in handy, because otherwise you could start breaking it down with 2's and you just keep dividing by 2 until you get something you can't divide anymore. And then you'll have all your prime factors there, and you're going to have to do a lot more work if you can't recognize that 144 is a perfect square already. So we bring that 12 to the outside, and what do we have left? We have a 2 left under the radical. So it's 12 times the square root of 2. Okay. Letter F. We have the square root of 48. And I'm going to break it down. I know that 48 is 6 times 8. Okay. 6 we break down into 3 times 2. 8 is 2 and 4. And we break that down into 2 and 2. So now if I'm looking for my pairs of common factors, I have a pair of 2's there, and I have a pair of 2's there. I suggest you use a highlighter because it does help you visualize what are the factors being used and what are the factors that are not. You could also circle it or put a box around it, something like that. So we bring out each of those pairs. So we have a 2 and we have a 2. And what's left under our radical? The 3 is all by itself, And then we simplify on the outside. 2 times 2 is 4 times the square root of 3. So the square root of 48 simplifies to 4 times the square root of 3. All right. So we're going to move on to our next page now. And we are going to remove variable factors. And we're going to follow pretty much the same approach. So the first thing we need to do is we are going to find our factors of our coefficient. So 54, I know, breaks down into 2 and 27. 27 breaks down into 3 and 9, which breaks down into 3 and 3. Okay, I'm going to use a different color for my variables. N to the 7th. So there's a little bit of a trick we can do. We can list out all 7 variables for n. So n, 2, 3, 4, 5, 6, 7. We've got 7 n's, right? N to the 7th power, 7 n's. I'll show you the trick on the next one. This one's the long one. We're going to do this the long way. So if I look at my common factors, I have a pair of 3's right there that I can take out. All right? So that's the only common numerical factor. Now, if I look at my variables, that's 1 pair of n's, that's 2 pairs of n's, that's 3 pairs of n's. So on the outside, I'm going to have n times n times n, and I have the 3 that we brought out. And what's left on the inside? We have a 2, a 3, and an n. So now we need to simplify. We need to combine like terms. We need to multiply. So we have a 3. N times n times n is n to the 3rd. And we have the square root of 2 times 3 is 6, n. Okay. So now, as I look at letter B, it's a little bit different in that we have something on the outside already. We have a negative m on the outside of this. That needs to remain there. So we need to keep that in mind, that it's sitting out in front and not forget about it. Now, 80 can break down into 4 and 20. 4 breaks down into the prime factors of 2 and 2. 20 breaks down into the prime factors of 4 and 5. And 4 breaks down into 2 and 2. Now, we have m to the 9th. So we're going to switch up colors. And instead of listing all of my factors, I'm going to take 1 m away. And we have m to the 8th as my other. So we have m to the 8th and m to the just m. And when I break m to the 8th down, it's going to be m to the 4th, m to the 4th. So what I did was I brought it to an even number that I can divide in half, right? Because I know the way we deal with exponents, we're just adding those exponents together. So I split it in half. Now I have a perfect square. So if I look at my pairs, I have a pair of 2's. I have a pair of 2's. I have a pair of M4's. So we start off, don't forget, we have the negative sign out in front. We put our numbers first. So we have our coefficients first. We have a 2 and a 2. And then we put our variable, the m that was out front, and the m to the 4th that we're taking out. And what's left inside of our radical? We have a 5, and we have a singular m. Okay? So anytime you have these odd numbers of variables, you're going to be left with one of that variable on the inside if you have an odd number. So now we just need to combine like terms and simplify. Negative 2 times 2 is going to be negative 4. M times m to the 4th is m to the 5th. And we're multiplying by the square root of 5m. So that is your simplification of the square root, or negative m times the square root of 80m to the 9th. Okay. All right, let's look at letter C. Letter C, we have the square root of 243x to the 5th So if I start figuring this out, I need to get some variables here. So I'm going to go with, or some factors. We're going to go with 3 and 81. 81 breaks down into 9 and 9, and I'm going to just stop right there. I could take this all the way to prime and say it's 3 times 3 times 3 times 3. I don't need to, though, because I already have a pair of factors right there that I can take the square root of. And as you start practicing this, if you start to see that you have a perfect square right here, you don't necessarily need to take it the next step down to its factors. If you can identify that 81 is your perfect square, you take the square root of 81 and you get 9. If you need to list out all your factors, or if you just want to do that out of comfort, that's no problem. So x to the 5th is going to break down. We're going to take away that 1x. So we'll have x to the 4th and x to the 4th splits into x squared times x squared. And again, we now have our pair that we can bring out. So we're going to have x to the 2nd, and we have 9. And what's left under our radical is a 3 and an x. So we have the 3 there and the x there that are unpaired right now. So 9x squared times the square root of 3x. Okay. I want you to pause the video here, and you're going to work on letters D, E, and F on your own. And then you're going to come back and check your work. Work on D, E, and F on your own, and then come back and check your work. All right, let's take a look at letter D. So letter D, we have the square root of 216y to the 7th. So we're going to break 216 down into its factors. So it's even, so I know I can divide by 2. 216 divided by 2 is 108. That is going to be, let's see, we can divide that by 12. And so we've got a 12 and a 9. 12 can break down into 2 and 6, which is 2 and 3. 9 is 3 and 3. And then y to the 7th, we're going to break that down, and we're going to have y to the 6th times y. So let's go through and highlight our matching pairs that we have. All right. So we have, if we work left to right, we have a pair of 2s, and we have a pair of 3s. So we can take those that 2 and that 3, and then y to the 6th, we actually didn't take it in the next step of y to the 3rd, y to the 3rd. Sorry about that. So we have our pair of y to the 3rds that we can take out. So start with our numbers. We have a 2 and a 3. We have the y to the 3rd, and we have the square root of what's left. We have a 2, we have a 3, and we have a y. 2 times 3 times y. Combine all our like terms. 2 times 3 is 6, y to the 3rd. 2 times 3 is 6y. Okay. Letter E, we have 360x to the 6th. So let's break it down by factors. 360, I don't know, that looks like it could be maybe 36 times 10. And 36 we know is 6 and 6. 10 is 2 and 5. I'm going to stop there with that one. X to the 6th, we don't need to subtract 1 because this one's even already. So we know x to the 6th is going to be x to the 3rd, x to the 3rd, because we're just splitting that in half. And so now we look for our pairs. We have a pair of 6s, and we have a pair of x cubeds. And so we bring to the outside the 6, the x cubed, and what do we have left inside of our radical? We have a 2 and a 5, which we know is 10. So you can start to see, if you can identify your perfect squares, that you can simplify your time working on factoring. Because if you don't recognize 36 times 10, you start bringing out 2's, and then you might have a 2 and a 3 as a pair instead of just having the 6 there. So it saves you taking it down levels. All right. Letter F. We have 320y to the third. Well, let's see what we've got. I don't know my factors, but I'm going to go with what I did the last time. We've got 32 and 10. So we're breaking it down into numbers that are a little bit more manageable to work with. 32 breaks down into 4 and 8. 8 breaks down into 4 and 2. 10 breaks down into 2 and 5. Now, you'll notice I paused. I didn't break down those 4s because I recognize that 4s are perfect squares already, but I also saw that it was lining up that I would have a pair of 4s there, and I would have a pair of 2s there. Now, we break down our variables. It's odd, so we bring y to the third, and this is essentially just going to be y times y times y. And again, we have a pair there of y's that we can bring out. And so we start with our numbers. We have 4 times 2 times y, and then what's left under our radical? We have a 5 and we have a y. 4 times 2 is 8y, and we have the square root of 5y. Okay. Now, finding higher roots. So this is our first portion that's coming to us from chapter 7. And you see here how it really makes more sense for it to be in this chapter than chapter 7. We're looking for the third root or fifth root or fourth root. So we're looking for higher than square roots. So that means instead of looking for a pair of values, we are looking for whatever that index is going to be. So for this first one, we're looking for, it's the third root, so we're looking for groups of 3 of something. So 27 is 3 times 9. 9 breaks down into 3 and 3. So we're looking for a group of 3 of something. We have 3 3's right here. So that's what it is. The cube root of 27 is just going to be 3. Okay. So when we're looking at the next one here, we've got the fifth root. So we're looking for groups of 5 of 32. So breaks down into 2 times 16. Well, 16 is 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. So I'm looking for groups of 5. So I have 1, 2, 3, 4, 5 2's in this problem. So that means we bring it out, and the fifth root of 32 is 2. All right, let's look at letter C. We're looking for the third root of 108. So again, we're looking for the third, so it's groups of 3 that we're looking for. 108 breaks down into 2 times 54. 54 is 6 times 9. 6 is 2 times 3. 9 is 3 times 3. So what groups of 3 of something do we have? Well, I have 2 2's. It's not a group of 3, but I have 3 3's that I can bring out. So we do that. We have on the outside a 3, and what's left inside the radical, 2 times 2 is 4, but in this case, remember, we need to show that this is the third root of 4. If you don't write your index in there, it's going to be marked wrong because you're showing me that it would be the square root of 4 when that's not the case here. We're looking at the third root of 4. Okay? So, again, I want you guys to pause, and I want you to do letters D, E, and F on your own. Do letters D, E, and F on your own, and then you can come back and check your answers. All right. Letter D. we're looking for the fourth root of 81. So we need to break down the factors. 81 is 9 times 9, we know. And 9s break down into 3 times 3 for each of them. So we're looking for the fourth root. We have a group of 4 3s, so we have 3 as our final answer for letter D. Letter E, third root of 64. So 64 is a perfect square, so that's 8 and 8. And that breaks down into 2 and 4 is 2 and 2. And we do that for both of them because it is a perfect square. We're looking for the third root of 64. So we have right there, we have a set of 2's that we can take out. And that's a set of 3 2's that we can take out. So we have 2 times 2, which is 4. Okay. Letter F, we're looking for the fourth root of 128. So we break that down. 128 is going to be 4 times 32. 4 is 2 and 2. 32 is 4 and 8. 4 breaks down to 2 and 2. 8 breaks down to 2 and 4. And 4 is 2 and 2. So we're looking for the fourth root. So we're looking for groups of 4 of something. So I have 1, 2, 3, 4 2's. So we have 4 2's there that we can bring out. So we bring out one of those. All right. Unfortunately, we have 1, 2, 3 2's remaining. So we need to show that we have the fourth root of 2 times 2 times 2, which is 2 times the fourth root of 8. Okay. All right, we're going to move on to our next page, and this is going to be kind of an easier one. We are going to be rewriting radicals and rational exponents, because something that has a fractional exponent can be rewritten as a radical and vice versa. So what do we have here in our rule? If the nth root of a is real and m and n are positive integers, then a to the 1 over n is equal to the nth root of a. And a to the m over n is equal to the nth root of a to the mth power. Okay? So when we look at this, what are we doing here? Your denominator of the fraction is your degree of your radical. The numerator of the fraction goes on whatever it's attached to under the radical. Okay? So let's work on this. Let's see how this is going to play out. So when we look at a to the 5/6, right, this becomes our index. Okay, and this is our exponent. So we rewrite it. We have the 6th root of a to the 5th power. And we can kind of see how this plays out. If this were 6 over 6, right, that would be an exponent of 1. We'd have 6, we're looking for 6, or groups of 6 of something, and we have 6 a's, we'd bring 1 out. And when you thought about our exponent rules, anything to the 1 power is just itself. So you can kind of see how these play together a little bit. So letter B, we have 5 times x to the 1/3 power. I want to point out one thing. Your exponent is only on the x. There are no parentheses there. That means that 5 stays out in front. Nothing happens to the 5. It stays out in front. It is not being affected by that exponent. So we have a denominator of 3. So we have the 3rd root of x to the 1st power. So we have 5 times the third root of x. Okay, letter C. Now we have parentheses, so that means everything in the parentheses is now our base. That is what's going underneath our radical symbol. And I'm going to include those parentheses when I write my radical. Why? Because this 2 has to distribute to everything. So we have an exponent of 2 in the inside the radical, and we are to the third power. So it's the third root, the index is 3, the third root of the quantity 54y squared. Okay. I want you guys to try letters D, E, and F on your own. Pay attention to the fact that letters E and F have the parentheses, so you do need to include those when you do your work. All right, letter D. We have an index. Our denominator is 3, so it is the third root of x to the fourth power. Third root of x to the fourth power. Now, can we simplify this and say it's x times the square or the third root of x? Yes, we can. Right now, all we're focusing on in these is converting from radical form to converting from rational, that fraction, to radical with a radical. All right. Letter E, we have the quantity 27x raised to the 1/3 power. So we're taking the cube root of parentheses 27x to the first power. We don't have to write to the first power. Since there's no exponent, you could drop those parentheses and it would still be correct. Letter F, we have 5x to the third 3/4 power. So again, we're looking at it. We need the radical. We need the parentheses 5x, and it's being raised to the third power. And we're looking for the fourth root because our denominator is 4. So we're looking at the fourth root of the quantity 5x cubed. And so as I look at that, there's nothing that you would be able to simplify from that just off the top of your head. All right. Now, this next part is going to be going the other way. We're going to take the radical and we're going to make it a fraction. Because sometimes this is easier for us to type into our calculators and work with, or sometimes fractions are just easier when we're dealing with multiple terms. So we have the third root of x squared. So we have our base is x. The numerator is 2, because that's what's under our radical, and we're taking the third root. And I'm going to erase that and write it with a smaller pen so that you can see it a little better. So we have x to the 2/3 power, right? The radical, this goes to our denominator, and then this is our numerator. So let's look at letter B. We have the square root of the quantity 4y to the 5th. So we have that in parentheses. It needs to stay in parentheses. And we have nothing written in for our radical, so we know that that is going to be a square root. So we have our 5 as our numerator, and then this we assume to be a 2 as our denominator. Letter C. We have the fourth root of 256, x to the 8th. So let's just kind of keep in mind here, 256, since these aren't in parentheses, 256 is to the first power, okay? 256 is to the first power, x is to the 8th power. So when we rewrite this, we rewrite it as 256 to the 1/4 power, x to the 8/4 power. Now, can we simplify this a little bit? Yes, we can. I'm going to just give you a spoiler alert. The fourth root of 256 is 4. And then x to the 8/4, 8 divided by 4 is 2. So that'll be x squared, right? And if we think about it, when we look back here, we're looking for groups of 4, and you have 8 exponent, or an exponent of 8, means you're going to have 2 groups of 4. All right. I want you guys to simplify letters D, E, and F, and I actually would like you to do the math to simplify. Okay, so do the math to simplify. All right, letter D. we're going to just rewrite this as y to the 3/4 power. Your index is your denominator, your exponent is your numerator. Letter E, we have the third root of 64, so we can rewrite that as 64 to the 1/3 power, and I'm going to just tell you right now that the 1/3 root of 64 is just 4. Letter F, we're looking for the fourth root of 128. So we've got 128 to the 1/4 power. Now, the reason we put it in radical form is it's easier to see these factors as they break down. But what I can tell you is this is ending up being 2 times 8 to the 1/4. If you simplify it, I just want you to get to this point today. All right. Now, going on to our final page of these notes. We are multiplying two radical expressions together. Now, when we multiply radicals, we can combine them under your radical symbol. All right, so when we're multiplying two radicals together, we can combine everything under one radical. Now, if you look at the textbook, it is going to show you that they're going to show you multiplying all the coefficients together first. I don't want to do that because to me, that means we need to combine something that we need to then break apart to find its prime factors. So we're going to start by rewriting letter A as the square root of 2 times 9. So we're going to group our coefficients to the front, and then we're going to have our variables at the back end. We have A, and we have A to the 3rd power. Okay, so our next step is break down our prime factors. 9 breaks down to 3 and 3. A cubed, we're going to have an A and A squared. And now again, we're looking for the square root, so we're looking for groups of 2 of something. So we have 2 3s there, we have 2 A's there, and we have 2 A's there. So when I rewrite this, we're going to bring out our common factors. So we have a 3, we have an A, we have an A, and what's left is a 2 and nothing else, right? Because 2 is the only piece there. So 3AA, that's 3 times A squared times the square root of 2. Okay. Now, that one was pretty easy. 2 times 9 is 18. I mean, you could figure out what you've got pretty easily from there. So let's look at this. So letter B is got an important piece. We have a coefficient out in front, and I'm going to highlight that in blue here, right? That coefficient in front needs to stay in front. It's going to come back at the end, and we're going to deal with it later. So now let's combine the rest of this under one radical symbol. So we have 6 times 18. Okay, so I'm going to just kind of shortcut some math for you here. We can do it and break 6 down into 2 and 3 and break 18 down into 3 and 6 and then 2 and 3. Actually, yeah, might as well do that. Let's do that. We have 2 and 3. 18 is going to be 3 times 6, and 6 breaks down into 2 and 3. So we're looking for groups of 2. We have 2 3s here, and we have 2 2s here. All right, so we've got our groups there, and you can see how I kind of drew, the loops around, and you can make it obvious what's happening here. So we bring out first of all, we need to remember that we're bringing down the 3 that was originally out in front, because that is still there. And now we look at what are we bringing out from the inside. We have a 2 and a 3, and what's being left behind is that 3 right there. So we have the square root of 3. So now combine your coefficients in front. 2 times 3 times 3. That's going to be 18 times the square root of 3. Okay. Now, had we done this a different way, we could see that we've got 6. I'm going to just off to the side here do a quick alternate reality for you. So we have 6 times 18, Well, could you have done 6 times 3 and brought out a pair of 6s? Yes, you could have. So if you can start to see these factors ahead of time, you can simplify your work, and now you would have just brought out a 6. So you have your 3 originally times 6, and you're left with a square root of 3, so you get 18 root 3. So you're going to get to the same endpoint depending on what factors you bring out. If you bring it all out to prime, then you're going to have to do a little multiplying at the end. If you can see the factors ahead of time, then it'll work out a little bit better for you. A little bit less work. All right, let's look at letter C. Now this is getting more complex. We got a lot of things going on here. The first thing I point out is that we've got a coefficient there and we've got a coefficient there that are both outside of our radicals, so we do need to combine those. So we're going to combine them into 21 on the outside. And we are going to draw on our radical and write in what we have. We're going to group our coefficients. We have a 5, and we have a 20, and we have an x and an x to the 5th. So let's start breaking out. What do we have here? What are our pieces? So 20 breaks down to 5 and 4. 4 is 2 and 2. X to the 5th is going to be an x, and then it's going to be x squared, x squared. So let's go look for our groups. What groups of 2 do we have? We have a group of 2 5s. We have a group of 2 4s. We have a group of 2 x's, a group of 2x squareds. So let's bring it all outside the radical then and see what we get. So we have the 21 that we started with, and I'm going to write it in blue just so we remember where it came from. So that's what we started with. We multiply it by a 5 that we're bringing out. We're multiplying it by a 2 that we're bringing out, and we're bringing out an x and an x squared. So when we combine this all together, 21 times 5 times 2 is 210, and we have x times x to the squared, and it's x to the 3rd power. X to the 3rd power. Okay, so that's our simplified form right there. Now, I want you to do letters D, E, and F on your own, and then come back and check it. Make sure you're paying attention to the fact that on letter E, you have a 4 on the outside, and letter F, you have a 3 and a 5 on the outside. You're going to have to make sure you keep track of those. All right, letter D. We are going to combine this all under one radical. We have 8y. We've got, 8 with careless whisper in the background. We have 8 times 6. And then we group, we've got a y and a y squared. So let's break down some factors, shall we? We've got 8 breaks down to 2 and 4. And 6 breaks down into 2 and 3. And 4 is 2 and 2. And now let's look for our groups of 2. So we have a group of 2 there, a group of 2 there, and a group of 2 there. So we bring out a 2, a 2, a y, and we have our radical, and we have a 3 that was unpaired, and a y that was unpaired. So 2 times 2 is 4y, and we have the square root of 3y. Okay. Letter E, we've got the problem that I reminded you that we have a 4 out in front of. So we combine everything under the radical. We start with our coefficients, 6 and 21. And we've got x to the 3rd, and we've got x to the 5th. Okay? If you want to combine those right away and see that it's x to the 8th, go for it. It'll simplify your work. We have a 3 and a 2. We have a 3 and a 7. And now we've got, we've got x squared x. This is x and x to the 4th. So let's look at our pairs. We have a pair of 3s. We have a pair of x's. a pair of x's, and a pair of x squareds. So we are keeping in mind the 4 that's out in the front, and then we're bringing out a 3, an x, and an x squared. X squared because 4 divided by 2 is 2. And then inside our radical, we have that 7 and that 2. So when we combine all of this, and I'm going to move my work a little bit. When we combine all of this together, we need to multiply 4 times 3, and that gives us 12. We have x squared, so that's 4 total x's, so that's x to the 4th, and it's the square root of 14. Okay. Now, letter F. First off, we're going to combine the 3 and the 5 that we highlighted right at the beginning. 3 times 5 is 15. And we're multiplying by the square root of, we've got a 12 and a 4, a z squared, and a z. So 12 and 4, we've got a 3 times 4. And I'm going to just stop right there because I already know my pairs. And z squared is z and z. So my pair right here is 4. And I've got a pair of z's that I can bring out. So we start with, we've got the 15 from our coefficients on the outside, and then we're bringing out a 4 and a z, and what's left inside our radical, we have a 3 and a z. Now we just need to multiply and simplify. 15 times 4 is going to be 60, z, square root of 3. Z. Okay. Now, problem 7.5, number 4 here is using a radical expression. So we are going to take a radical expression and use it to figure out a fact. So you can estimate the metabolic rate of living organisms based on body mass using Kleiber's law. The formula R equals 73.3 times the 4th root of m cubed relates the metabolic rate, R, measured in calories per day, to the body mass, M, measured in kilograms. What is the metabolic rate of a dog with a body mass of 18 kilograms? Okay, so our most important piece of information here, let's highlight our word problems. We've got a body mass of 18 kilograms, and we know that body mass is M. So we're going to substitute that in. What are we trying to find? We always look at the last question of the setup, and it's saying, what is the metabolic rate of a dog? So that is what we're trying to find. We're trying to find the metabolic rate. So let's do this. So R is equal to 73.3 times the 4th root of 18 to the 3rd power. So we can rewrite this so that it's a little easier for us to type into our calculator. We do 73.3 times 18 to the 3/4 power. And I'm going to change the color of that so it's a little easier on the background. 3/4 power. So when you type it into your calculator, it would be 73.3 times 18, use the little caret button, and then put parentheses in 3 divided by 4, or just type in 0.75. You can also use the math route, click the math button, but you have to put your index in first. So that's why it's a little more complex. It's a little easier to just do it as the fractional, the rational exponent route. So now let's do our math on it. You need to multiply 73.3 times 18 to the 3/4 power, and you get, your calculator will tell you, 640.56, and our units, we were told, are calories per day. Calories per day. Okay? So now letter B tells us we're going to use the same formula with a dog for a dog with a body mass of 35 kilograms. So we are going to do the exact same work. We have the same formula, R equals 73.3 times the fourth root of 18 cubed, not 18 cubed, because now we're doing 35 cubed. All right. And when you go ahead and do that math on your calculator, you are going to get 1054.76 calories per day. All right. So this one, there's no real logic. We're not going to be doing these by hand. We are going to just be typing these in and using our technology that we have available for us. That is the end of lesson 10.2a, simplifying radicals, including the pieces from lesson 7.5. This is where we're going to work on tomorrow. We're going to do our practice, and it's going to take some time, but this is a lesson where you must be showing your work. If you're not showing your work, you will struggle. So there you go. That's all we have for today, and I will see you